All right, 12.3b, more inscribed angles, but now you're going to have a tangent line and a chord. So let me start you with a theorem. It says the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. This is the inscribed angle theorem still, but with a tangent instead of two chords. So notice this right here is tangent and a chord. It's still the intercepted arc, so arc BC here, cut in half, okay? Or if they come out this way, this intercepted arc, whatever the measure is, cut in half will give you this angle, okay? Or this angle. So it looks a little different, but you're doing the same thing. And there is an animation that will help you see like why it's the same. If you go to page 1797 and just hit play on that little animation, it shows you a inscribed angle with two chords, and then they move that vertex until one of them is tangent, and you'll see it's exactly the same arc with the same angle that we started with. So if you want to check that out, go right ahead. We're going to do a few problems, not a lot. This is a pretty short lesson, and then we'll go from there. All right, here's the thing. First of all, this is arc BED, but my program doesn't give me an arc, so it's a pointed arc, but it's an arc. Example 1 here. It says AC is tangent to the circle, meaning it only hits the circle at point B, okay? If the measure of arc BED, so BED, this arc, they're saying is 214 degrees, okay? What is the measure of angle? So this is an arc, this is an angle, but they are related to each other, remember? Angle DBC. So we're looking for DBC, which is this angle. Okay, and I showed you a little bit of this yesterday. We know that a circle is 360 degrees. So I know that if I took all of this, it's 360. Which means, since I know that this piece of it is 214, I can do 360 minus 214, and I will get arc DB. Okay? When we subtract that, 360 minus 214, I get 146. Okay, so I know this arc is 146. If that's the case, I know my angle is half of that, because this angle right here opens up to that arc. Okay, my angle is going to be half, so we're going to say half of 146 is my measure of angle DBC, and that comes out to 73 degrees. Okay, now maybe you saw a different way. There is another way here, and they're the same number of steps. It's just a matter of where you want to go first. Maybe some of you saw it this way. I have this angle that is the inscribed angle for this arc. Well, if that arc is 214, I cut that 214 in half, and I get this angle. And this angle, so 214 cut in half would be 107. Okay, now you can find the angle next to it because this is a straight line. So if this is 107, then this has to be 180 minus 107, which is 73. So notice it doesn't matter which way you do it, you're going to get the same angle measure. It's just a matter of what one you see. Okay, you might see it one way and your buddy might see it another way, and that's fine. They both work. Okay. Second and final example for these ones. Example 2, it says in the diagram KJ is tangent. So this line right here is tangent to the circle. It only hits at J. Okay. What are the values of X and Y? Here's what you need to look at. If we start with X, okay, X opens up. Actually, let's do this in a different color. X goes here to here. Okay, that's this angle. The intercepted arc for that is this arc? Do you know the measure of that arc? You should. That arc is also the intercepted arc for this angle, right? So if this angle is 35 and has the same arc as this angle, then x has to be 35, okay? Another way you could think of that is I could say, because this is 35, then this arc is going to be 70, and because the arc is 70, then the angle is going to be half as much, so half of 70 is 35. But if you see they open up to the same arc, they are the same angle, okay? Okay, then we need to find y. And the way that I would do it, I would look at, let's see here. Let's switch colors. If we look at this angle, okay, what you should notice is this is a diameter, which means this arc is 180, and if that is 180, then this is 90. Okay, so I have a triangle here that 90, 35, and y are its angles, which means that has to add up to 180. So if you take that 125 away, y ends up being 55 degrees. Okay, so that's one way to find y. Does anyone see another way to find y? If you look, this is a diameter. I know this piece of it is 70, so what is this piece of it? It would be 110 degrees, right? To add up to 180. So 70 plus 110 is 180. And now that is my intercepted arc for this angle, right? If that angle is y and its arc is 110, we're cutting that 110 in half and getting 55 for angle y. So like I said, there are multiple ways to get to the answers on a lot of these. So take a look at that, see which way makes the most sense to you, and go with that way. That's it. Short and sweet again.